Chapter 5, Historic Risk and Return. And we're going to cover a lot of different terminology and computations associated with risk and return. And then we're going to look at some historic data for fairly standard asset classes. So here's a quick outline. We'll talk about the determinants of interest rates, a little theory. We'll talk about inflation and the CPI, how to quote and calculate rates of return both within 1 year and over multiple years, and how these things are quoted is specific and important. We'll talk about mean returns or average returns. We'll talk about the arithmetic mean and the geometric mean and the difference between these things. We'll talk about expectations, expected return, and a deviation about that expectation, a standard deviation about that expectation. We'll talk about ways to calculate this using both historic data, but then also sort of expected data, states of nature and probabilities. We'll talk about risk versus risk premium, the terminology here. We'll talk about Sharpe ratios and other ratios of risk and return. We will talk about the normal distribution and confidence intervals and probability estimates that you can compute assuming normality. We'll talk about this idea of tail risk and value at risk, abbreviated capital V, small a, capital R, which is a measure of tail risk, a measure of essentially left tail risk. And then we'll talk about return distributions, tail risk, and VAR if the return is not normal, if there is positive or negative skew or positive or negative kurtosis. And then we'll talk about cumulative returns and geometric mean. So the returns over periods of time and how the geometric mean relates to that. Okay, so that's an outline, lots of stuff to do. Let's start talking about interest rates. So the determinants of interest rates are just the price of money. $10 for $100 is 10%. And it's the price as a function of supply and demand. Funds are supplied from savers, and funds are demanded by corporations and governments and consumers. And just to get some basic terminology, we'll talk about the real return as small r and nominal returns as capital R. This is the amount you get, and inflation as I. And inflation can either be backward-looking, realized inflation, or forward-looking expected inflation, and depending on the context, it'll be one of these two. And we could put an expectations operator around the I. I'm not going to do that. We'll just know. And so here's the relationship, and this is the Fisher equation, and it says 1 plus the real return times 1 plus the inflation rate is equal to 1 plus the nominal return. And if I have positive inflation and a positive real return, then the nominal return must be larger. And often we'll see that these things are sort of estimated by adding them together. If I take the nominal plus inflation, I get something that's pretty close to the nominal. We will do the actual equation as opposed to the estimate, but you'll see this. So here's the theory. The theory says that lenders choose some real return, some amount of increased purchasing power they wish to earn based on risk. In addition, they estimate expected inflation, which is going to be the change in prices, and that's going to be a loss in purchasing power. And so they set a nominal rate such that they earn a nominal rate that's equivalent to the amount of real return that they want to earn plus the amount of purchasing power they expect to lose. And we can think about this relationship both ex ante and ex post. We can think about this beforehand with an expected inflation that sets a nominal rate. And so given some real return that I need to earn and some expected inflation, I can compute the actual nominal dollars I need to get. Or we can think about this ex post or after and a realized real return. So given some amount I earned, essentially less the amount of inflation I incurred, this tells me my realized return. And in this particular case, the I is realized inflation, and here the I is expected inflation. Okay, let's take a look at some data to see if this actually makes sense. And again, I'm not trying to prove the theory. I'm just going to look very quickly to see if we can find some evidence that supports this idea that expected inflation affects nominal rates. That's what the theory I'm trying to test here. So let's go to the spreadsheet. So here's an Excel spreadsheet, and I have the FRED codes for CPI and 1 year T-bill rates. I'm going to get quarterly data without any sort of adjustment. They're both starting at the same date, so I have the one date function in there, and I'm going to click Get FRED Data. And here's the data. And what I'm going to do now is take a look. Here's the idea. And I'm just going to take these dates and pop them over here so that I have them. And what I want to do is I want to see what happened to prices over the year immediately preceding this date. And so I compute the percent change, and I see that the price of this basket of goods increased by 1.22%, 1.23% over this time period. And in the next quarter, the prices over the year were up by 1.04%. And so effectively, this is an annualized inflation rate for this quarter. And what I want to do is I want to look at the rate that at this particular point in time, people contracted with the US government to earn. This is the T-bill rate. And so here is CPI or inflation, and here is the T-bill rate. And what I have is the contemporaneous inflation and the dollars that people needed to earn from contracting with the US government. And what I want to do is compare these all the way down. And so now I have, given that people realized a 1.23% inflation prior to this point, is this a reasonable expectation going forward? And did this inform the T-bill rate that people want to earn? And I can see that I'm going to have this for 230 quarters all the way through April of 2020. And the last thing I'll do is I'll compute the real rate. And remember, the real rate is going to equal 1 plus the nominal rate divided by 1 plus the inflation rate, all of that minus 1, and I get, oh, made a mistake. There it is, 1.78%. And so this is the realized, well, essentially real return that they expect, not the realized. This is the expected real return. Okay, so now I have 3 data points, and you'll see that I have already computed them here. Again, those are the same numbers, and now I will graph them. And remember, what we're looking for is some sort of evidence that inflation and the T-bill rate are related, and I get a graph. And I can see that here I have inflation, I have the T-bill rate, and I can see that, yeah, there does seem to be some relationship. When inflation is very high, people are expecting a higher inflation going forward, and so they contract with a higher, they contract for a higher nominal rate. And again, all we're looking for is some idea that there is some relationship between inflation and these nominal rates that people contract. And again, here's the real return, and we can see that if they were really, really good at this, this would be, well, arguably relatively flat. It bounces around, and so maybe people aren't as good at predicting inflation as they would like to be. All right, so we demonstrated that there's likely a link between expected inflation and the nominal rates that lenders are going to charge on bonds, in this particular case, the Treasury bill. There are multiple measures of CPI. Here are some links to check these out. The first thing we'll look at is this idea of CPI for workers, CPI urban, and chained CPI for urban. There's also CPI X food and energy, excluding food and energy. And let's just take a quick look at those 2 data series just to see something interesting of why we might exclude food and energy. So we're back with the spreadsheet, and here I have the FRED codes for CPI and CPI less food and energy, and I've already pulled the data, so we'll just go to the sheet where I have the data pulled, and here it is. I have the CPI for all urban consumers, all items, and here I have all urban consumers, all items less food and energy. And I want to take a look at this data. So again, I'll pull my months over to here, and now I'll look at the percent change in prices over 4 quarters a year, and I can see that. I'm going to change that format. Here I have a 5.26% inflation over that period from 1990 to 1991, and 5.50%. This is CPI-U, and this is CPI-U X food and energy. And now I can click this, and I can get all the data going down to here. Okay, so quickly, let's just graph these. Let's see what it looks like if I graph them. Put that there, and what I'll do is I'll highlight all the data. I'll go to Insert, Recommended Charts, and I'll take a line graph. I'll click OK. Click the graph, go to Move Chart to its own sheet, and that'll make it a little bit bigger. Okay, and I can see that the orange line is X Food and Energy, and the blue line is all urban, and I can see that it was a little higher for a period of time, and then a little lower, but I can also see it's less volatile. Okay, so let's take a quick look and see what I get when I look at back to my data, and I can compute the average, and I can see again changing that to 2.33%, and here I can see the average was 2.31%. So they're pretty much the same in terms of the average. Let's look at the standard deviation. STDEV. Let's see how volatile these are. And again, changing this to percent. Okay, so that's the number here. This is the key. And here I'm going to graph just these percent changes. I'm going to go to Insert, again, Recommended Chart, and now I'm going to graph the percent change. Click OK. I'm going to move this to its own new sheet. Click OK. And here I have the price levels. And here I have essentially the percent change, which is inflation. And I can see that the CPI, change that very quickly by moving this, clicking font, changing that to say 16, which is a bigger number. And I can see that the orange line is the X Food and Energy, the blue line is all products, and I can see how much more volatile it is. And so this would be a reason why people might, because the averages over time are roughly the same, but they might look at a less volatile measure of inflation, the X Food and Energy. Other important, relevant things to consider when examining CPI and using it as a basis for measured inflation are some of the inherent biases. Substitution bias, quality bias, new product bias, outlet bias. All of these can affect whether or not CPI is really measuring how much more people are spending and how much the cost of these goods is going up. We're not going to spend a lot of time on this, but here are some links. Take a look at that. But just know that we will use CPI as a proxy for inflation, and there are issues. It can be biased, so take a look at those.